Let's learn about square roots. The square root symbol is formally known as a radical symbol, and it's the part that looks like that. When you square root a number, you normally put a plus and minus sign out front, but today we're just going to be talking about the positive square root of a number. It's called the principal root. So we'll just kind of ignore the negatives for today unless we're given a negative to begin with. If you square root a number and the number is not a perfect square, your answer is irrational. That means that the decimal goes on and on forever and it's kind of crazy. So using your list that I gave you in class with the perfect squares and square roots on it, having that out and next to you while you go through this video will be very helpful. Especially since the first example we're going to do without a calculator. So instead of just typing the square root of 34, we're going to figure out what the square root is by estimating. It is not a perfect square. If you look at your list, 34 is not on it. But it is in between two numbers. The numbers it's in between are the square root of 36, that one's slightly larger, and the square root of 25. So you'd agree with me that 34 is somewhere in between those numbers, kind of closer to 36 than 25. So the square root of 36 is 6. The square root of 25 is 5. So it means the square root of 34 is going to be somewhere in between 6 and 5. So we're thinking the answer is going to be 5 point, and then a decimal that's pretty close to 6. So maybe 5.8. You can put the little approximately sign in front, and you're welcome to type it into a calculator to see how close you are. Go ahead and try 1B. You'll check with your neighbor tomorrow. So this is kind of a side note, for the properties. You know how you wouldn't leave a fraction 2 over 4 because it's not simplified all the way? You would reduce it to 1 over 2. We have to do the same kind of thing with square roots. If we look at a square root and it can be simplified, we need to do it. So the square root of 25 is 5 because 5 times 5 is 25. So since it's 5 by 5, the answer is 5. Well, what about 12? Can we write the same two numbers right next to each other that when we multiply them together give us 12? No, we can't do that. So what we try to do is we try to find a perfect square that does go into 12. Well, 2 and 6, 2 times 6 is 12, right? But 2 is not a perfect square and neither is 6. So what about 4 times 3? 4 is a perfect square. 3 is not, but that's okay, because we're just doing as much as we possibly can. Notice I'm writing the perfect square first. When you write it like that, we can break the square root sign apart and take the square root of 4 and the square root of 3 separate. Do we know the square root of 4? Yep. It simplifies to 2. Do we know the square root of 3? In other words, is it a perfect square? Will that one reduce? No, so we'll leave it. And our final answer is that. That's one way to do these. If you had Ms. Carlton last year for geometry, or Mrs. Middleton, you may have learned the factor tree method. So if you understand the first way I did it, in this column, way number 1, that's fine. If you need a second way to understand how to do these, then the factor tree method might be for you. When you make a factor tree, you just figure out any two numbers that multiply together to give you the number underneath. So the only two numbers that multiply together to get 25 are 5 and 5, besides 1 and 25. So when you do a factor tree, you circle the prime numbers. So the 5s are both prime. And the story goes that the number underneath the square root sign is in jail. And when the number in jail can split up and have a partner, so two of the same numbers, those two numbers can partner up, get out of jail, one of them is free, but the other one is caught. So one of them shows up and is out of jail. Let's try this with the 12. It doesn't matter what numbers we break the 12 into. We could do 3 and 4, we could do 2 and 6. 2 is a prime number because we can't further divide it into any other numbers. 6 comes from 2 times 3. I'll circle the 2, I'll circle the 3. So look at, we have a pair of 2's. These two 2's partner up and get out of jail. They're free. They're no longer underneath the radical sign. But one of them's caught, so it's right there. The other one disappears. That 3 doesn't have a 3 to partner up with, so it stays underneath the radical sign in jail. So 2 square root 3 is the same thing I got over there doing the perfect square method. So I'm going to keep going back and forth between both methods, try to give each way a chance, and then make your decision at the end which one you like better. And if you can do both, that's great. So now we'll do product property. This is if we have two things, 2 square roots that we want to multiply together. Since they are both underneath the square root sign, we can multiply 5 times 20 and put the answer underneath one square root sign. 5 times 20 is 100. Can we simplify that? Yeah. 100 is a perfect square. The square root of it is 10. Well, that was nice because 100 was a perfect square. What if we multiply 2 and 10 together? Those equal 20. Is 20 a perfect square? No. So let's figure out what numbers we can multiply together to get 20 using perfect squares. So I know 2 times 10 equals 20, but 2 isn't a perfect square, and neither is 10. What about 4 times 5? 4 is a perfect square. I'm going to write it first. 5 is not. And when we break them apart, the square root of 4 times the square root of 5, we can simplify this one. The square root of 4 is 2, and the square root of 5 is not a perfect square, so we leave it, and that's the final answer. Same thing over here for the factor tree method. The square root of 100. Let's say we didn't break it into 5 times 20, or 10 times 10. Let's say we did 2 times 50. 2 is prime. 50 divides into, let's say, 5 times 10, and 10 breaks into 5 times 2. All right, so what happens now with the partners getting out of jail? Well, the 5 and the 5 partner up. They get out of jail. They're free. But so do the 2's. That 2 and that 2 partner up and get out of jail. So they're also out of jail. When they're both out of jail, you multiply them together. And 5 times 2, sure enough, is 10. Let's do the same thing with the square root of 20. So let's break it into 2 factors. Maybe we use 2 and 10 because it's right there. So 10 breaks into 2 times 5. And here we have one pair of 2's, so they escape and are free. The 5 doesn't have anybody to partner with. It's still underneath the radical sign in jail. So 2 square root 5 and 2 square root 5, those are both the same final answers. Next, quotient property. My advice to you, if you have numbers that are divided, is to see if each of those numbers are perfect squares. Is 25 a perfect square? Yep. Is 16 a perfect square? Yes. So we can separate them. Take the square root of the top, it's 5. The square root of the bottom is 4. We cannot reduce 5 over 4, so we're done. What about 128 and 2? Is 128 a perfect square? Is the square root of 2 a perfect square? No. So let's not do that. Sorry if you just wrote it down. Erase it. What happens if you divide 128 by 2? You get 64. Is 64 a perfect square? Yep. We can reduce that to 8. And we don't really need to do the factor tree method for those. So let's try some more examples. So I'm going to do A, C, and E with you. And then you'll do B, D, and F on your own. So the square root of negative square root of 50. That negative sign out front, it's just going to stay out in front there. I'm going to deal with the 50. I'm going to start by doing a factor tree. 5 times 10 is 50, and 2 times 5 is 10. So it looks like I have a pair of 5s that get out of jail, and I have a 2 that is stuck in jail. So negative 5 square root 2 is my final answer. How could we do that using perfect squares? Well, what's a perfect square that goes into 50? The biggest one that goes into 50 is 25. 25 times 2 is 50. So we'll square root 25, square root 2. We know the square root of 25 is 5, and we cannot simplify the square root of 2. And don't forget the negative sign out front. Now for 2C. When I look at 49 and I look at 81, those numbers kind of stand out to me as being perfect squares. So I'll square root the top and square root the bottom and get 7 over 9. That does not reduce any further. Now for 2E, we have a number out front. We're just going to copy it out front. We'll deal with the square root of 12 and put the 2 as part of our final answer no matter what. So let's try the perfect square method. We did this one up above. Do you remember what perfect square goes into 12? It's 4. 4 times 3. So we have the 2 from out front, the square root of 4, and the square root of 3. So there's that 2. The square root of 4 is also 2, so those will get multiplied together. And the square root of 3 doesn't simplify. So this final answer, when we times those 2's together, is going to be 4 square root 3. Good luck with 2B, D, and F. I will come back in a moment and put the answers so you can check to see if you're getting them right. So here are the answers. Please make sure that you can show your work. It does not matter to me which way you do these as long as you can do them.